Writing absolute value equations and inequalities. Okay, absolute value equations and inequalities are going to be set up exactly the same way each and every time. In between your absolute value bars, you're going to have the difference between the actual amount and the ideal amount. Then you're going to have your sign, less than, greater than, or equal to. And then you're going to have it equal that to the amount of your variation, what you can vary. So, for example, all numbers less than 3 units from 0. So, my actual amount I'm going to say is x. My ideal amount is how far away it is, so that's from 0, so 0. And my variation is going to be this 3 units. So when I write it up, I do, in my bars, I do x minus 0. And then that's going to be less than 3. And basically, I can write this as the absolute value of x less than 3. And there's my answer. The second one, all numbers more than 2 units from 6. So 6 is going to be my ideal amount this time. X is still my actual amount. And this time my variation is 2 units. So I'm going to have the absolute value of x minus 6, close my absolute value sign, is greater than, because it's more than, 2. And that's all I have to do to write my absolute value inequality. So let's look at a word problem. The ideal diameter of a piston for one type of car engine is 90 millimeters. The actual diameter can vary from the ideal by at most 0.008 millimeters. So we need to find the range of acceptable diameters for the piston. Okay, so D is going to be my actual diameter. I don't know what it is. I need to find the range. 90 is my ideal, and 0.008 is my variance. So I'm going to have my absolute value bars, my actual minus my ideal, and this time it needs to be at most, which it needs to be less than or equal to 0.008. Now, it's a less than, it's an and statement, so I'm going to have D minus 90 is less than or equal to 0.008, and D minus 90 is greater than or equal to negative 0.008. Now, when I solve each one of these, I'm going to add 90 to both sides. So this one I get D is less than or equal to 90.008, and this one I'm going to get D is greater than 89.992. So basically, therefore, that's what these 3 dots stand for. 89.992 is less than or equal to D, which is less than or equal to 90.008. And this is the range of diameters I can have for my piston. Another example that we have is an ideal weight of one type of model airplane engine is 33.86 ounces. The actual weight may vary from the ideal by at most 0.05 of an ounce. And we need to find the range again of the acceptable weights for this engine. So I'm going to say W is my actual weight this time. 33.86 they said was our ideal. And our variance is what it can vary, which is 0.05 of an ounce. So I have the absolute value of the actual minus the ideal is less than or equal to, because it can't be any more, it's at most, than 0.05. Now, again, it's an and statement, so I'm going to have W minus 33.86 is less than or equal to 0.05, and W minus 33.86 is greater than or equal to negative 0.005. 0.05, sorry. Okay, on both of these, you're going to add 33.86 to both sides. This one you get W is less than or equal to 33.91. And this one you get W is greater than or equal to 33.81. So, my weight in my engine can vary from 33.81, which is less than or equal to what the actual weight can be, which is less than or equal to 33.91. So this is the range of my weight of my engine for my airplane. Now let's write some absolute value equations and inequalities from graphs. So, to find the variance, you're going to count the distance each point is from the middle point, which is the ideal amount. So here's my first one. Notice, there's no shading, there's no lines, I just have 2 dots. That means it's an equation. Okay? So, if I look, I've got one at -3 and one at 3. Now the halfway point between those two is 0. So there's my ideal, and that's why I put this dotted line. Now, I'm going to be 1, 2, 3 units from here to here. And from here to here, I'm as well 3 units. That is my variance. So my ideal was 0. That was the middle. The variance is 3. So I write my inequality. Or actually, this one was an equation. The absolute value of x minus the ideal, which is 0, equals your variance. Basically, to sum it up, you can do the absolute value of x equals 3. We know that 0 would be the ideal amount. So let's look at number 2. Now, notice this has 2 inequality graphs, so it's going to be an OR statement. So, if I have right here at -4 and 2, my halfway point this time is going to be here at -1. So that's my ideal. Now, from here to there, I have 1, 2, 3 units. And from here to here, I have 3 units. So that's my variance. So my ideal is -1 and my variance is 3. It's an OR statement, so that means it's going to be greater than the variance. So I have the absolute value of x minus my ideal, which is -1, is greater than, and notice it's not equal to because I have open circles, 3, which is my variance. So basically, if I do that, keep, flip, change, that becomes x plus 1, same thing as subtracting a negative. So I can do the absolute value of x plus 1 is greater than 3. And there's my equation, or my inequality. Okay, this third one, now first thing I need to look at is it's a greater because I have 2 inequalities going out, and notice it's going out away from the ideal, so it's greater than the variance. The middle is going to be right here at -2. Now notice, they're both 1 unit away from the middle, the ideal number. So that means my ideal is -2, my variance is 1, and I've got an OR statement, so it's greater, okay? So the absolute value of x minus the -2, there's your ideal, is greater than or equal to. It's equal to this time because I've got closed circles. 1, which is my variance, which basically, remove those, do the plus, make that a positive as well. Remember, keep, change, change. So it becomes x plus 2, the absolute value of that is greater than or equal to 1 as your inequality. Okay, this last one, I have 2 closed circles. Now I need to find the middle between these 2, and since they're together, everything in between these 2, it's going to be an AND statement. So the middle of between 6 and -2 is at this +2. From here to here, I have 1, 2, 3, 4 units. And from here to this 6, I have 1, 2, 3, 4 units as well. So my ideal was 2, my variance is 4. So I'm going to have the absolute value of x minus 2 is less than or equal to 4. And I did less than because it's an AND statement. And it's equal to because I have closed dots on these 2 ends.